Hey everybody! Welcome to our first real unit in Chem 2, which is all about stoichiometry. Now, stoichiometry sounds like a really crazy word, not like anything you've ever heard of before, but the word stoichiometry literally translates to measuring elements. So metry is the measuring part, where that stoichio means elements. I forget what language it's in, but I know that that's what it translates into. And stoichiometry is really what chemistry is all about. With chemical reactions, you have a starting amount of a substance, and using stoichiometry, you could figure out not only how much product you can produce, but also how much of another reactant you need in order to react with all of that other reactant. It really is what relates everything to everything else in chemistry. It's the backbone of everything chemists do. If you can't do stoichiometry, you're not going to be a very successful chemist. We are going to do this literally all year long. If you decide to take AP chemistry, you'll do it in AP chemistry. This is just something that you have to know how to do because it is so vital when determining or studying chemical reactions. And this unit's actually going to go by pretty quickly because I feel like once you can do stoichiometry, if you can do one, you could really do all of them. It just kind of takes a lot of practice to get used to doing it. And I find that my students normally are very successful with stoichiometry because we do so much practice. And you're going to do this in all of the labs that we do from now on. So it really is intertwined with everything else you're going to see. Learning goals. The first one, you will understand mole ratios and be able to predict the mass of a product from the mass of a given reactant and vice versa. So given a chemical reaction, you should be able to determine how much product could you form or how much reactant is needed to form X amount of product. You'll be able to identify the limiting reactant in a chemical reaction and calculate the mass of unreacted excess. So sometimes not all of your reactant is going to react. You might have some left over, and you can calculate how much of that is left over by doing stoichiometry, again, because it literally translates into measuring elements. And another important thing for chemists to do is to determine the percent yield. And you'll be able to calculate percent yield by comparing the theoretical yield to the actual yield in a reaction. Using stoichiometry, you could figure out how much you could theoretically produce from a reaction. But sometimes experiments don't always give you 100% of what you want. You might produce a 75% yield, 75% of what you should produce. And that's where percent yield comes in. Like I said, this unit is super important. It should go by pretty quick, but we'll do lots of practice in class. And I hope these videos help you. So go on to the next video all about mole ratios if you're ready to start.